Let's now recap some of the lessons learned from the global temperature analysis. First off, remembering that the forecasts themselves depend on so many factors that can be controlled by the investigator. And this can be very dangerous, certainly something that we want to keep remind ourselves of. So just as a quick example, let's say that we wanted to check out the global temperature data, a very widely used data set. And there it is. That is a picture of the last few years of the temperature anomalies. And if I was a researcher and I just decided to fit a stationary model to this, then I might go through AIC5, see that an ARMA 4.1 was reasonable, and then I might go through and do plots.wge and look at the global temperature and say, well, the ACFs, that's the ACFs. I don't know how consistent they are with white noise, but they only have one that are outside the limits. Maybe I'm somewhat sold here, and the spectral density certainly doesn't look like it has much going on in terms of correlation. So I might then do the Young box test and note that it fails to reject white noise at k equals 24, fails to reject white noise at k equals 48. So I might have some solid ground, or feel like I had some solid ground to stand on for fitting this stationary model, full well knowing that the forecasts have to go back to the mean. So if I was to forecast these, I would see that these forecasts would slowly go back to the overall mean from the data set. And that could be used to support a political position or scientific position one way or the other. But that was my choice. It was my choice to fit a stationary model, whereas somebody else might choose to fit a non-stationary model. And so if we were looking at AR trans this time, doing something like that, I might take out a difference. So I'd use AR trans to take out a first difference, a 1 minus b. And then I might decide, you know what, this was the original data set in its ACF, and that was the difference data set in the ACF. But I might decide to take another difference out. And in taking that additional difference out, I would get something that looks like this. Not a tremendous difference between those two. Certainly the ACFs don't look to be too much beyond any limit. This one looks a little bit more extreme, but not too bad. So I might go and see what stationary components are left. And I look at that, and again, I get a 4.1 after I've differenced it twice. So then I might try to defend that using the Young box test, and note here that it fails to reject white noise on those residuals. That's on the residuals of that fit. So I might feel like I have solid ground to stand on for this model, but this one being a non-stationary model, again being a non-stationary model that I chose to fit, again at k equals 48, seemingly not any evidence against the white noise residuals. So at that point, I might proceed and say, I like this model. Of course, it was my choice, and this model would give us very different results, certainly projecting temperature anomaly increases and quite extreme increases into the future. Two models telling very different stories, both just my choice, both defended by white noise residuals. So if I was to put these side by side, just for comparison, two models that can tell very, very, very different stories. So we want to keep in mind that, again, this problem with forecasts is that they depend on the forecaster. They depend on the researcher. So for some advice, realize that the model you choose will result in a certain type of forecast. So carefully choose the model to be used. And again, as we move on to some of these other takeaways, we'll note, I'll just go ahead and skip to the end, that that's when you're forecasting. If you are consuming the forecast, if you are looking at somebody else's research, you want to also remember that they had the choice. So be sure to ask questions, scrutinize, be respectful, trust but verify, but know that the results of those forecasts could very well likely be the choice of the model from that researcher. And a quick example of that, that's number 5 here, but a quick example of that is just an easy Google search will, if you look at the images, will produce for global temperature analysis or global warming, will produce a lot of different analyses. And this is one that I just picked off right off the front page. Was it has the green or the actuals, those are the ones we've seen, that we see in our analysis. The black are the modeled ones that were modeled, the actual modeled ones from somebody's model. But the red and the blue are what I really wanted to show. Is one takes off, one of this model, this SRES A2 takes off.